Alright, so my name is Kyle McNulty, and today we are going to be going over the 2007 AP Calculus FRQ question number 6. So the first part of the question, as stated here, you're going to find the first and second derivative of the function k root x minus ln x for x is greater than 0, and k is a positive constant. So we're going to be using basic rules of differentiation in the beginning here. So we'll write out the function f of x equals k root x minus ln x for x is greater than 0. So for the first derivative, in order to solve it easier, we're going to rewrite it. So kx to the 1/2 minus ln x. That way it's going to be easier to use the chain rule. So now for the next step, we're going to use the chain rule, and you'll get 1/2 k x to the negative 1/2. Reminder, the k is just going to stay the same because the k is a constant. And then, so we have the derivative of ln x, which is going to be 1 over x. So this is our first derivative. Now we'll move to the second derivative. So we'll start by writing out the first derivative, as that's what we're working off of. So 1/2 kx to the negative 1/2 minus x to the negative 1, again, so we can do the chain rule a little bit easier. So the next step, chain rule again here. So you're going to get negative 1/4. K is still a constant, that's going to remain untouched. We'll throw that on top, times x to now the negative 3/2, since you have to subtract 1 from your exponent. Now for the x to the negative 1, again, you're going to throw that in front, so that's going to be minus a negative 1 times x to now the negative 2nd. So rewriting this, second derivative is negative k over 4, x to the 3/2 on the bottom here, plus 1 over x squared. Alright, now we're going to move on to part B. Alright, so for part B, we are going to find the value of k that gives f a critical point at x equals 1. So, first of all, it says justify your answer at the end. So before you even do this problem, if you have no clue what you're doing, a way to get an easy point is just by saying second derivative test. Because you're trying, in the second part of the question, you're trying to determine whether it has a minimum or maximum, you know that you're going to be using the second derivative. Okay, so now we'll go into it. In order to find this, we're going to plug in 1 for x and then find our value of k for the first derivative. So 1/2 k times 1 to the negative 1/2 minus 1 over 1. So that's the equivalent of 1/2 k, because the 1 and negative 1/2 is just going to be 1, minus 1. So this is all equal to 0, and you'll get 1/2 k equals 1, so k is going to be equal to 2. So now you're going to do the second derivative test. So we want to find if it's positive or negative at k equals 2 for our second derivative function, which is right here. I'll rewrite it, negative k over 4x to the 3/2 plus 1 over x squared. So x is going to be 1, k is going to be 2, and we'll see if we get a positive or negative number. So negative 2 over just 4, because 1 to the 3/2 is 1, plus 1 over 1, so that's going to be negative 1/2 plus 1, that's going to be positive. So because it's going to be concave up, that means we have a relative minimum at x equals 1. So relative minimum at x equals 1, and then again back to the justification. It's because the second derivative test, which is what we did right here, we found out that it's a positive value. So concave up, so relative minimum at x equals 1 because of the second derivative test. Alright, moving on to part C. Alright, so part C reads, for a certain value of the constant k, the graph of f has a point of inflection on the x-axis. find this value of k. So basically what we're going to be doing is finding when the value of the second derivative is equal to 0 and finding when the value of the original function is equal to 0, then setting both of those k values equal to each other and finding our value of k that'll work. So we'll start with the second derivative portion and we'll write that out. So from up here we have negative k over 4x to the 3/2 plus 1 over x squared, and this is going to be equal to 0. So the first step here is we're going to be trying to get everything on this side so the k will be isolated. So we'll multiply everything by x squared to start. So we're going to get negative k root x, which is equivalent to x to the 1/2, over 4 plus 1 equals 0. Then we're going to subtract the 1 over, so we'll get negative k root x over 4 equals negative 1. Then really quickly we can just cancel out the negatives on both sides. So we have k root x over 4 equals 1. Multiply the 4 across and we get k root x equals 4. Then k equals 4 over root x. So now for the original function, which we have back up here, k root x minus ln x. We need to find when this is equal to 0. So scoop this up. And we need k root x minus ln x equals 0. So we're going to add the ln x to the other side, get k root x equals ln x. Divide both sides by root x, so k equals ln x over root x. Now we're going to set these equal to each other. So we have the k for the original function, k for the second derivative. So 4 over root x equals ln x over root x. Multiply both by root x, and we're going to get that ln x equals 4. So it's also known as the exponent needed to make ex is going to be 4. So you know your value of k is going to be, x here is going to be e to the 4th. So then we can plug this back in to our function up here, which is 4 over root x. So then when you plug in this x here as e to the 4th, you're going to get 4 over e squared. Alright, there's our answer. And then for additional practice, some problems you can do. Chapter 3.1, number 45 through 48 for differentiation practice. And then chapter 3.2, number 27 through 30 for more practice with the product and quotient rule. And again, these are going to be in the book that our class has provided to us. Alright, thank you for watching, and I hope this has helped you with solving this FRQ problem. Thanks.